All right, welcome back. This is the actual mechanics of the lab. What you need is some sort of tube to have a string running through, similar to the diagram that I had on the board. Well, it was there. Now, there's some metal tubes that we've had around here, and if I find those, we're going to pull those out. The metal tubes have the advantage of the fact that they're not going to bend over like a normal soda straw will. The disadvantage is that the edge might be a little bit rougher, and I've seen some strings break. No one has gotten hurt, but you're slinging a mass around, and if the rope breaks at the wrong time, the string breaks at the wrong time, then that mass is going to go flying. The one time that it really potentially could have been, I've gotten better about that, but one time it potentially could have gotten better is, or gotten bad, fortunately the rope, no one was there. It flew in the right direction from my point of view. Now, the way you deal with the soda straws, ordinary soda straws, is that I basically took a straw, I cut it in half, and I want to reinforce it. And so I basically put a slit up one side of it, just to give you a better idea of what it's looking like. So normally I put a slit into it, and then basically I'm going to lodge this inside of it. And so now I've got it reinforced with itself. Now the string, I have a string right here. I have a 100-gram mass at one end like this, but I need to get the string through here. And see if I got something in my pocket to get that through. Nope, not from that. There we go. Now, there is a certain amount of coordination involved with this lab. In the past, I've had students, there we go. I've had various students try it. Some students are better than others or luckier than others, whichever the case happens to be. And, all right, now it's coming out the other end. I don't like my fingers there, it keeps getting repelled. There we go, got it pulled through. I now have the string pulled through. I don't want it on the cut end. And so I'm going to extend that slightly there. All right. So now to this end down here, this is going to be my bottom end. I'm going to loop this mass. I had a loop there. Let's see if I can get that one back. Now the heavier mass is not the one that's going to be slinging around. So if it's not real secure, it'll fall off, and depends on how many times you've tried it, but it's not a huge deal. This one right here, I need to somehow attach it to the smaller mass. I picked this happens to be a 20-gram mass, but the experiment does not have to be done with a mass where it's printed on there. And now I tie it on, and I'm going to do a double knot because I don't want this thing sliding off. All right, so now it's like this. If the thing broke right now, my computer would probably be in trouble, or me. So now I'm going to, and this is part of the coordination, because the thing became unattached down at the bottom. All right, so there it is at the bottom, there it is at the top, and I'm going to be slinging this thing around. And so I'm going to turn the camera, and I'll move back, and I need to get it going. Now that thing is spinning around like that. Notice if I let go of this bottom mass, what's going to happen? Well, part of what happened just then is that I've got the two straws sort of nestled into one another like that, and that bottom straw, basically the straw started sliding, and I started getting into the string started hitting the cut piece of straw. And so I need to apply enough pressure to keep that from happening, but not so much that I'm holding on to the string. And there is sort of the art to it. You don't want to press too much, but you don't want to press too little. And so let's try that one again. As I'm swinging this thing around, now, if I let go right now, what's going to happen to this bottom mass? Well, notice it goes up. I don't want it to move up because then it's not in equilibrium. And so I need to slow down some. and I need to readjust. I think that, or my recommendation is use a little bit of tape there to keep that attached in place. Or, hey, I got a better idea. No, that's a temporary fix. So never mind. Forget that better idea. A piece of tape probably would work wonders right there. I got my fingers near the top to keep it from collapsing over. Because sometimes, one reason I'm doubling up is I've seen straws that just basically get bent over, which changes the radius. All right, so now I got this thing swinging around like this. Swing faster, it goes up. And I don't want that. Now, ideally, if I swing too slowly, it's going to fall. But I really want to get that right balance. I want to swing it just as much. All right, I can feel that thing going up, so I ease up just a bit. So now I would time how long it takes for that mass to go around. So a couple of different measurements here. I'm going to do just a quick measurement of this one for for a couple of rotations here. All right. So I'm going to do it for when it's in front of me. So we're going to do 1, 2, let's try that one again because I think I messed up. And that's part of this lab. All right. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, that took 12.5 seconds to go do 20 revolutions. I would do this for different masses hanging down at different masses hanging at the bottom. But let's go through one quick analysis here.